Okay, so this is our next slideshow. This is next slideshow, and this is going to continue what we were talking about, but we're going to do a couple problems with bases. So just fire away here. So what I want to know is the pH of a solution, 0.125 molar methyl ammonium chloride. It's a base, and so we don't know its acid ionization constant. So we're going to have to do this one a little bit different. We're going to use the base formula, equilibrium formula, find the OH, and then from the OH we can find the H. So here's our equation, and what our answer is going to be one of these five guys here. So what we're going to do is we're going to set up an ice table. We're going to look up the so just like the other problems, what you do is you set up the ice table. Here's your initial concentration, and so what happens is the direction moves to the right, so you lose your reactant minus X, and it increases by the same amount because they have stoichiometry ratio of 1 to 1 to 1 to 1. All right. Okay. So now we're given the base ionization constant, but the table is set up to find H, okay, or H3O plus. So we can't use the KB that we're given, but what we can do is we can change the KB to the Ka formula using the relationship of Kw equals K times Kb. And then simply rearrange the equation for Ka, and then we get Ka is 2.27 times 10 to the minus 11. Right, and then we just follow through what we did before. We set, here's our equation, and we have x times x, all divided by this value. We're going to assume that it's very, very small. This number is very, very small, so it won't affect this value at all, so we can just ignore x. And then so it's going to be x squared divided by 0.125 equals this value, and then x squared equals 2.084 times 10 to the minus 12, and x equals 1.69 times minus 6, which is this value and this value. We're just interested in this value, which is help us find pH, and then pH is equal to minus log of that value, 5.77. Okay. All right, next problem. Again, we're going to do the same kind of problem. What is the pH of 0.1 molar solution of ammonium bromide? And we know the Kb of NH3, and so what we're going to do is find the Ka. So the equation is given here. We solve for the Ka, and then what we're going to do is follow through. And so we get Ka equals Kw over Kb, 5.6 times 10 to the minus 10th. So you got x squared again, and so forth, and there's your answer. Okay, so that's all for this section. I could have put it on the last slideshow with the acids, the acids, but decided not to. And I'll get going on the next slide.